Hey guys, welcome back to mathapple101, and today we're going to learn about the rules of exponents. So let's get right into the video. So first of all, we need to learn about about the structure of an exponent. So the number is called the base, and the exponent we're going to call either the exponent or the degree. So basically, in this case, a 3 is the base, and 5 will be the degree. So now that we know the structure of an exponent, now let's get into some rules. So here, if you multiply two exponents with the same base, then the product, it will be the same base plus the sum of the 2 degrees. So that's the rule. And now let's try an example with this rule in action. So in here we have 2 to the power of 3 times 2 to the power of 5. This would be 2, because it's the same base, all we need to do now is just add the 2 degrees. So then 2 to the power of 3 and 2 to the power of 5, that'll be 2 to the 3 plus 5, which will be equal to 2 to the power of 8. Or we could write it, if you work it out, it'll be 256. Now let's do the exact same thing here. As if 3 to the 7th power multiplied by 3 to the 10th power. This would be 3, because it has to be the same base, but to the power of 7 plus 10, because over here, it follows this rule. Also, you have the same base, and you add the exponents. So, and that'll be 7 plus 10, which is equal to 3 to the 17th. And now let's get into another rule. So now this is kind of like the multiplication. It's like the multiplication rule, but it's a little bit different. But here we are working with division. So instead of adding like we did before, we have to now subtract. And it only works with common bases, just like before. So now let's try an example. So here we have 2 to the 3rd divided by 2 to the 2nd. So I have here common bases 2 and 2. And now here, all we need to do is 2, and then you have to subtract all the exponents. And then you'll get 3 minus 2, and that will give you a 2 to the 1st, or which is equal to just 2. And now let's look at another example. So here I have a 2 to the 7th and 2 to the 2nd. And here all you have to do is just keep the common base and subtract the exponents. And now we need to subtract those exponents, and then we got our answer. Then 7 minus 2, which is equal to 2 to the 5th, or it is equal to 32. Now let's get into another rule. So in this example, it's the negative exponent rule. So basically, if you have a number with a negative exponent, then that'll be equal to 1 divided by the number by the positive exponent. And now let's see an example of that. It might seem confusing at first. So now 2 to the negative 1, that is equal to 1 divided, so we just did 1 divided by 2 to the 1st. So so we basically, we just divided 1 by 2, but now it's the positive exponent here, not the negative. And that just removes the negative. And that'll be equal to 1 over 2. And now let's look at another example. So here, I have 3 to the negative 7, which is equal to 1 divided over 3 to the positive 7. And there's our answer. And now let's look at our final example. So here, we have 5 to the negative 9. So all we need to do is just 1 over, and then 5 to the positive 9. Okay, and now let's get into another rule. Okay, now this rule is called the power to a power rule. So basically, if we have here, so an exponent to an exponent, okay, so a number with an exponent, and then another exponent outside the parentheses, that'll be equal to x. Sorry, that'll be x to the two exponents multiplied. And now let's look at an example of this. So now here we have 3 to the power of 2 to the power of 3, and this will be 3 to the power of 2 multiplied by the power of 3, which would be 3 to the power of 6. Now let's look at this example. So here we have 18, and then just 9 multiplied by 10, because we are using this in this rule. So we have 9 as y, and then 10 as z, and then we just multiply 9 and 10, and then that will give us 18 to the 90th power. Okay, so now here is our last example. So here we have 7 to the third power to the fourth power. So here, I think I know the drill. So we have 7 to the 3 times 4 power, which is equal to 7 to the 12. Now let's look at another rule. So here we have another rule. So this is so it's kind of like the exponents rule, but it's like so this rule is kind of like a distributive property, but with exponents. So what this says is that if you have if you have a set of a monomial, and then you multiply it by an exponent, it's kind of like a distributive property, but with an exponent. You just distribute these two. So now you have x to the z and y to the z, because you distributed a z to there and z to there. And now let's look at an example of this. So here, we have like a 3 times 5 to the power of 2, and this is equal to 3 to the half multiplied by 5 to the half, because we distributed these two. And now here we have 7x to the power of 2. Now here, all we can do is just distribute it. So just distribute the exponent, and that'll give you 7 to the power of 2 multiplied by x to the power of 2, which you can say is 49x to the power of 2. And now let's look at the final example. And here we have 8 times 10 to the power of 3. Now here, all you have to do is just distribute it. 8 to the power of 3 multiplied by 10 to the power of 3. See, this is helpful because you could just do instead of saying it's 80 to the power of 3, and I can have a more exact answer, because all you can say is a to the power of 3, and then do that, and then just add 3 zeros from the and now let's look at our final rule, and this is our easiest rule so far. So now it's basically any number to the power of 0, it will always be 1. So now it's a very simple rule. So for example, 17 to the power of 0 will be 1. So basically, any number to the power of 0, it will always be the whole number 1. So now, and 35 to the power of 0, of course, it will be 1. So any number to the power of 0 is 1. And now here, for example, we have like a crazy monomial here. So we have like 9,654 xyz. But it's to the power of 0, so it will be 1. So yeah, and that's it for our rules of exponents. I hope you learned something new, and please subscribe. Bye.